too. We're going to be solving linear systems.
How?
Ooh, graphically.
Nice. Well, when we have a linear relation, you can represent that with a graph of a line. And every single xy point on that line is a solution to that equation. Now, we're dealing with systems, and we know that for a system, the solution is that pair xy that satisfies both equations. So if there's a point that happens to lie on both of those lines, I guess we have ourselves a solution. In solving graphically, here's what we're gonna do.
Step 1.
Graph the first line.
Step 2.
Graph the second line.
Step 3.
Locate the point of intersection.
Step 4.
State our solution as being that particular point of intersection. Let's see some examples. All right, we're going to solve this system graphically. Well, just to be extra safe, I'm going to make sure I label my axes. And at some point I'll label my scale. I have a tendency to label my scale last. It's just how I roll. X plus y equals 5. You could graph that from something form. I would prefer to say that y is equal to 5 minus x. Ah, this I recognize. We've got a y-intercept of I don't even know, 5. And a slope of -1. So we've got more points going around this way. I'm going to play some connect the dots. It's going to be great. That's line number 1 done. 1. There's a 1. 1. 1. And line 2. 2x plus 2. So y-intercept of 2. Slope of 2. So rise 2 over 1. Shabam. Shabam. I'm going to play connect the dots. This is old hat at this point. Get me out of here. Oh boy. Help. Nailed it. Like boss. Do-do-do. Do-do-do. This is line 2. At this point, this is where I like to indicate my scale just so I know it's not going to conflict with any of the space. So I'm going to put my 1 here, and let's put a 3 up here. Just so I know it's out of the way. I don't like it when stuff overlaps. Pain causes me pain. I'm in pain. Our solution is the point of intersection. There it is. This is where those lines intersect. So we're going to state that that is our solution. Here's how we do it. Our solution is a point. It's a point x, y. That particular point that works for us is when x is 1 and y is 4. This one is done. Boy, I wish there was another example.
Oh, I'd love to. Oh, wait.
What?
There it is. It's
Where?
almost as if all my dreams have come true.
Yay.
All right. So we're going to do the same thing. We are going to start off by making sure that we label our axes. So we have y up here, x over here. And again, we do have to label our scale, but what Mr. Athide says is that he doesn't like when things conflict and overlap, and I agree. I don't like when things overlap. It's just too much for me.
It's just wrong.
In every single way.
Like a few ways.
Every single one. You're right. Okay, so we have 2 equations. I'm going to graph this top one that I'm going to call equation 1 first. And it is in slope-intercept form, which is, so nice. Our intercept, or y-intercept, is at -3. And then our slope is -1 over 2. So our rise is -1 over 2. 1, 2, 1, 2. And we could go ahead and do this both ways if we so desire. I'm personally a fan of continuing dots all the way to either side. You really don't have to, as long as you have 2 dots. Realistically, you could draw a line. But that's just the way that I roll. And here we go. Beauty of a line. Whoo, mama! It's a good looking line. And we're going to label it with the Uno right over there.
I actually really like that blue.
Right? It's pretty. We also, I'm going to use this tealy, greeny, turquoisey color for equation number 2. And equation 2 is also already nicely in slope-intercept form for us. We have our y-intercept of 5, and our slope is rise 3, run 2. Rise 3, run 2. We could also go backwards to get to those points there. We are going to play connect the dots, because it is a childhood favorite. Oh, nice. I'm actually going to make that thicker, though, because it's kind of a light color. It doesn't really pop as much as I really want it to.
Yeah.
So, is that going to be thick enough? No, we'll see. Oh. She is perfect. And that is our equation 2. And our solution is that point where those 2 lines intersect. So she's right over here. Of course, we still have to label our scale. That's something we talked about at the beginning, but we need to make sure that we actually remember to do at the end. I'm going to say this is 1 here, and this is 1 over here. Doesn't conflict with any of my lines. I'm pretty happy. So, we have to indicate what our point or final solution is. It is not just enough to graph it and draw this dot. We have to write, well, our solution happens to be a coordinate point, and that coordinate point occurs when x is -4 and our y is -1. And there we have it, folks. Another fantastic example completed.
Neat. Whoa! There's words in this problem. Something about Cam's cabs and Tammy's taxis. Okay. We have to determine the distance for which each company has a lower cost. Well, if we're going to graph this, we're going to need equations. And if we need equations, we're going to need some variables. Oh boy. We're going to need some let statements. So, let. I'm going to use D for distance. But what, like centimeters, meters, kilometers? Well, this is per 100 meters. So I'm going to say the distance is measured in hundreds of meters. So if D is 1, that's 100 meters. If D is 2, that's 200 meters. If D is 7, that's 700 meters. And we'll let C represent the cost. Not in cents, but in dollars. It might seem like that's an obvious thing. You say, what's the cost? Well, we'll typically state it to other people as a combo of dollars and cents. But because we're dealing with numbers, we have to specifically say what those numbers represent. Those numbers represent doll hairs. So that's what we're doing. Now we can develop our equations. Equation 1 is purple. And for Cam's cabs, the cost is going to be $4 plus 25 cents per 100 meters. So 0.25 multiplied by whatever number of hundreds of meters have happened. And equation 2, there's no base fee, so the cost is just straight up 50 cents per 100 meters. 0.5 times the distance. Now, if you want, we can rewrite these just a bit, because First of all, when I deal with slope-intercept form, I'm personally used to seeing the variable first before the intercept, but also a decimal? How in the heck does that work? I don't know. I'm going to convert that to a fraction. So 0.25 we know to be a quarter. C is 1/4 D plus 4. And same over here. Instead of 0.5, I'm just going to call that 1/2. And that might just make it a little bit easier to graph. Here I go. Ba-da-da, 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 ba. I'm going to go with bar ball. Cost is 4. Plus, where am I? Oh yeah, 1/4. Up 1 over 4. Up 1 over 4. Up 1 over 4. Up 1 over 4. Wicked cool. And Tammy's t-axis. Intercept is 0. And then slope is 1/2. Up 1 over 2. Up 1 over 2. Up 1 over 2. Ba-cha, 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 ba-cha. Doo. Ba-cha. Oh, there it goes. I see a point of intersection. But let's just be extra careful. There's one thing we want to make sure we don't forget. Is whatever the heck these axes are. C is dependent on D. C must be our vertical axis. D must be our horizontal axis. The point of intersection whoops, I know spelling. Is when DC is equal to 16, 8. Because there it is right there. But that can't just be our final statement here. We're asked something in context. We need to respond in context. Determine the distance for which each company has a lower cost. Well, this is the lower cost all the way up to that point. And afterwards, old purple line is the lower cost. Pink is Tanny's. So Tanny's taxi has a lower cost all for here and here and here up to that point. And that was 16, about 16 hundreds of meters. And after that point, it's all up to Cam's cabs. Wicked!
Neat!
Totes!
Cool.
Word. Well, there's some practice work. I'm not sure where it's located. Oh, wait, it's listed right here at the bottom of the page.
Oh.
Found it. So if you want to give that a gander, a look-see, and then give it a shot, give it a stab, give it a whirl, give it a try, give it a spin, give it a go. Tibbs, you got nothing?
Got nothing.
Wow.
You can do it!
Yeah, you can. And you should, because you should practice this. As per usual, you have questions, let us know. Okay? We're here.
Yeah, we're here for you.
I just want to answer questions. Yeah.
Any hoozles. That's it. That's all. Take care. Adios, muchachos. Ciao for now.